2.2, this is called definite integrals. So let's talk about that little symbol that you guys were worried about. This kind of, it's not really an S, but it's kind of like a flattened S shape. This is called an integral. Behind the integral, there is going to be a function. So I'm going to call it f of x. And we're going to put our dx after it because that's part of the symbol. This is the function that you are finding the area under. Or the curve. I guess we can also say the word curve, right? That's the curve you're finding the area under. On that little integral, you have from a to b, where a, of course, is the lower limit, is what they call it. We usually say lower bound, lower limit, same thing. And b, of course, is your upper limit. And typically, whatever this dx, dy, dz, whatever this is your variable of integration. It's telling you what you are finding the area of compared to. Do you know what I mean? So, a couple things before we get into how that all applies, a couple things I want to talk about. If we were to graph this, so we take that f of x function and we graph it. So let's say I do a beautiful graph and it looks like this. Any ideas of what that graph just was that I kind of sketched? Fine. Awesome. Good, good, good. All right, so this is our function. So this is our f of x function that we just graphed. If I wanted to say it goes from a to b, I could say maybe here is my a and here is my b. So the area I'm shading, or I'm finding the area of, goes from one to the other. So I'm looking for this area. Now, here's the only other tricky thing, and the reason I drew it this way is just so you realize, when the area is above the x-axis, this is a positive area. So when it's below the x-axis, it's a negative area. Yeah. All right, so what we're going to do today, the only thing we have to do today, is we are going to start by 1. I want you to graph the f of x function that's in the integral. Okay, so whatever function is behind that symbol, you're going to graph it. All right. Then 2, I want you to draw vertical lines at, I'm just going to say A and B. We know what those are, right? The lower and upper bounds. Just like I kind of did on here, I drew a line at A and a line at B. Step 3, we're going to calculate the area using area formulas today. All right, so it's either going to be square, rectangle, triangle, trapezoid, circle, some type of area you already know the formula of. All right? So here we go with a very, very easy starting one. Example number 1. Example 1. We're going to do the integral from -3 to 2 of 6 dx. All right, so I'm going to draw my graph. So 6, how do you graph 6? 6 is just a horizontal line at 6, exactly. So I'm going to go 1, 2, 3, 4, 5, 6. I have a horizontal line at 6. Now I'm going to draw vertical lines at each of my bounds, or each of my lower limit and my upper limit. So at -3, I have a vertical line, and at +2, I have a vertical line. I am finding that area between those bounds. So the width of my rectangle I have here, from -3 to 2, is a distance of 5, right? -3 to 2 is 5. And the height of this rectangle is 6. So what would the area of this curve, or the area under this curve? 30. So technically, you just evaluated your first integral of 30. Feels special, don't you? All right, let's try this one. All right, example number 2. We're going to do the integral from -1 to 3 of x plus 3 dx. All right, so I'm going to graph this. How do you graph x plus 3? Up 3. Okay, up 3. And then my slope is up 1 and over 1, right? All right, so technically this is my graph. All right, now I have to do vertical lines at -1 and at 3. So I am finding this area right here. What kind of shape do we have this time? We have a trapezoid, exactly. So to remind you, its area equals 1/2 the height times base 1 plus base 2. So this is 1/2. The height is the distance from the lower limit to the upper limit on the x-axis. So to go from -1 to 3 is how far? 4. I agree. 4. Base 1 is the distance from here to our line. Now the easiest way to do that is kind of to evaluate it. If I take -1 and plug it into my function, -1 plus 3 is 2. I agree. Plus, same thing here. If I take my 3 and plug it into my function, 3 plus 3 is 6. So I have 1/2 times 4 times 8, or 16. I agree. That's it. You just evaluated your second integral. Give me some questions before I go on to example number 3. I only have 5 examples, so. Questions? Yeah. It's just we're making your life a little easier. And we'll get easier and easier. All right, here's example 3 if there's no questions. All right, this time we're going to do an integral from -4 to 4 of the square root of 16 minus x squared dx. So, does anybody know what shape that makes? No? Oh. It's a semicircle. So let's talk about why it's a semicircle, okay? First of all, this is your function. If I set that equal to y equals the square root of 16 minus x squared, right? If I go ahead and square both sides to get rid of that square root, I'd have y squared equals 16 minus x squared. And then if I add that x squared to the other side, I'd have x squared plus y squared equals 16. It's a circle, right? The reason it's only the half or the top half of the circle is when you square root it, they only have the positive. Remember, when you square root a variable, you should have the positive and negative. So that's why they don't have the bottom half. So this is a semicircle that has a radius of 4 in all directions. So here's my semicircle. Whoops, that's not a very good drawing. We'll pretend that's good. All right, find the area of a circle. It's pi r squared. Whoops. But it's a semicircle, so I'm going to divide it by 2. All right, so let's plug in what is, because we're finding this area, right? What's the only thing I need to plug in here? What is the radius? From the center of the circle, it is 4, exactly. So our area is pi 4 squared divided by 2, or the area equals 8 pi. Very good. You're still doing okay? Is it anything with the graph? Is it to look and see what a graph's like? Exactly. Yeah, when in doubt, graph it out, right? Okay, so here's example number 4. I'm going to make it just a little tougher, but I know you guys can figure this out. I'm going to go from negative, whoops, that's supposed to be a -1. Try that again. From -1 to +1. And let's do the graph, the absolute value of x plus 2. It'd be a v, and how does that v move? Up 2, exactly. So let's graph exactly that. So you have this up 2, and you have a v that goes, it's got a slope of 1 in either direction, right? There's our graph. Now, we're going from -1 on this side to +1 on this side. So we're looking for this area from here to here. So tell me what those shapes are. What is that? It's 2 trapezoids. Now, it's 2 trapezoids that, although you can't tell from my picture or my drawing, they are actually symmetrical, right? Times it by 2. Very good. All right, so let's do it once, and then we'll times it by 2. So we have A equals 1/2. The height is, and we're only doing one of the trapezoids, so the height of one of the trapezoids is 1, right? From here to here, the distance or the height of it is 1. The base, how high is this length right here? That's 2 plus, how high is this one? That would be 3. If you took -1 and plugged it into our function, -1, the absolute value of -1 is 1, plus 2 is 3. Right? That's the easy way to do to find out what the value is. Okay? So then we have, technically, this is 5 divided by 2, or 5/2. So this side is 5/2, and if this side is 5/2, times it by 2, we get, it is 5. Very good. No, none of these have labels at all. Okay. We doing okay? Any questions at all? This doesn't seem hard, right? All right. Last one then. The last example is going to kind of fit in the last few of them you have in your homework, only because it's a little more, I know you guys don't like this, I'm going to say the word, it's a little more abstract, because it's not a set number. What I mean by that is we're going to do an integral from 0 to b of 4x dx. All right, so if I graph this, how do you graph 4x? It's skinny. You start at the origin, and it's up forward over 1, right? So here's our line. Whoop. All right, I'm going to come out here and say this is b, because I'm going from 0 to b. So what shape am I making? Whoops, I'm going to say that's b. It's a triangle. I agree. Out here at b, it's making my triangle. All right. So I'm finding the area of this triangle. Now remember, the area of a triangle is 1/2 base times height. So we have A equals 1/2. The base is the distance from 0 to B. What is that length? B, exactly. That length is B. From 0 to B is B. The height is to here. Now that B falls in this function. So the easiest thing to do is to take that B and plug it into our function. What do we get? 4B is the height of our triangle. So we have 1/2 times B times 4B, or 1/2 times 4B squared. So the area of our triangle is 2B squared. Exactly. All right. Okay. So you know how on the last one, let me go back up for a second. We talked about how if you just take like -1 and plug it into the function, you get the value out, right? Same thing down here. If I take, get out of my way for a minute. If I take B, because that's the line where it's falling at, and plug it into my function, I get 4B. That's the easiest way to do it. Questions? That's as hard as it gets today. We're good? Awesome.